Good afternoon, everybody. My name is Tim Brown. I got a tough spot here after lunch. I'll try to keep everybody awake and engaged. We're talking today about security virtualization, and the content of the course is going to be based around how to transition the traditional physical network security elements into virtual elements, and why you'd want to do that, and what you gain by it. If I could just get a quick show of hands, how many people in the room are on the offensive security side? In other words, red teaming or anything like that? Okay, just a couple. And what about defensive side? Everybody else pretty much defensive? Okay, great. How many of you are responsible or have logged into a firewall in the past 6 months? Okay, a few. All right, great. So this is going to be sort of a mix of technical and business content, so it should be enough for everybody. I want to talk really briefly about us, and I promise I'll keep it to like 30 seconds. Network Utility Force, we were here on Monday doing an IPv6 class. What we do is pure consulting, so we don't sell any hardware, we don't sell any software, we're entirely vendor neutral, and our background is basically service provider engineering. So everybody that works at Network Utility Force in an architecture role has worked at places like Comcast and Cox. I came from 7 years at Cisco in theater leadership in emerging markets, so I spent a lot of time overseas. So I've got some experience there, and my background is actually based in network architecture. Security's, I wouldn't say new for me, but I've only been focused on it for about the past 7 years. So we have a close partnership with Walker & Associates. Some of you are familiar. Walker & Associates is a value-added distributor. They basically can provide and resell pretty much every product you can imagine on the network and telecom side. They do full-scale integration. They've built containerized data centers, that kind of thing. They've built central offices. So if you have any questions about that, please come see us. These are some focus areas for Network Utility Force that are specific around the federal and DoD sides. So, not only do we do advanced network architecture, we also do a lot of IPv4 to v6 transitions, big data, machine learning, and, of course, security. So that's going to be our topic of today. I want to talk a little bit. I'm sure everybody's seen this diagram. It's pretty common in the security industry. But I think everybody pretty much understands the basics of security, the idea that if you have an attacker that wants to get into your network or your element, they're going to go through these phases of the kill chain. And so what we're going to talk about today is ways that security virtualization can come back to that kill chain and help mitigate some of these threats. A lot of the people in this room I know have been involved in acquiring and implementing firewalls. Some of you have been involved in handling the application security side and the host security side. We're going to talk about all that. So where I talk about firewalls, we're also going to expand into some different components here. All security is really a balance. You guys have heard this several times over the past few days. A balance between risk, protection of risk, and ease of use. So it's great. You can put a box in a locked bank vault somewhere or federal vault somewhere, and it will be perfectly secure. You've got the machine turned off. You've got interception systems to prevent air gapping or things like that. That's great, but it's a little bit difficult to use. So what we're going to try to do is give you some techniques to, not only enhance the security, but I think the key thing is to try to figure out ways to help distribute the policy a little bit, and we'll talk about some ways why that would be important. There's no doubt that protecting systems has a cost. So, and who you're protecting the system from, if it's a nation-state actor, it's a very different threat model than anything else. There's a great book by Adam Shostak of Microsoft called Threat Modeling, who hopefully some of you have read, but we're actually going to be giving away a copy of it after the event. So, I'll talk a little bit about that. But anyway, long story short, how are systems protected? So I put the most important one up top. I think it's something a lot of people ignore. If you look at a lot of the common threats that you see, particularly in the enterprise space, but also in the federal space, people are actually your biggest vulnerability. And that's something I think a lot of security people don't actually talk about. Training your people and training them to detect those threats and communicate them up to a security operations center is critically important. This presentation has nothing to do with that, but I don't want to go without mentioning it because I think a lot of people don't mention it. In red, I have 3 very common mechanisms that everybody kind of uses to protect systems. Firewalls would be, probably public enemy number one when it comes to protecting systems. But a firewall is not enough. You also have to have a lot of other components in the network and in the systems to secure yourselves. One of the components that you really want to have is an intrusion detection or prevention system, and that is functionally separate from a firewall. So when I talk about an IDS or an IPS, what I'm talking about is a system that's analyzing network traffic and traffic hitting a host, and potentially dropping that traffic, but it's not based on the traditional firewall model of the rules all the way up from layer 1 through layer 4. This is something that's looking at the network traffic and saying, hey, that signature looks like an attack, I'm going to drop the packet. So it's not enough to just put firewalls in place. Everybody, I think a lot of people think that it is, and it's not. And then the other side of that IDS, IPS, initially I was talking about the network side, is also the host side of the security, right? So being able to understand when a host has been penetrated. And usually the way you do that is through file and systems integrity monitoring. There's a company downstairs called Tripwire who specializes in that. I'm sure some of you are familiar with. Basically takes a hash of every file in the system, stores it in a database, and the moment that that file changes, you know that something's happened on that system. And it may or may not be an attack, but it's worthy of investigating by your SOC. The other thing here is just systems monitoring more generally. See a host with a ton more network traffic, you know that something's up. If you see a host that's suddenly using a lot more CPU than normal, you know that there's a problem there or something you need to investigate. And storing that baseline data over time is very important. But what we're really going to talk about today is segmentation and how we're going to get to the point where we can separate out our security policy in very small elements. A couple other things I mentioned here, network telemetry and monitoring. So that's taking NetFlow data or other packet data, storing it into a system and doing historical analysis on that. That's a fantastic way to spot anomalous traffic that might be sent there by a hacker. The wire does not lie. So if you've got a system there that's sniffing the wire, you'll know that something is up on that host. And that's something that a lot of security systems tend to ignore. The other thing I want to mention is intelligence, right? So a lot of people don't have very good threat intelligence programs. I can't understate the importance of that, and I can't overstate it either. It's very important that you have a list of potential threats that you might be seeing, and you have ways to look for an increase in those threats and to understand the climate that those threats come from. So there's been a lot of situations that we've seen over the past year or so where a good threat intelligence program might have easily prevented a breach. So I don't want to ignore that. We help with all this, by the way. I'm happy to talk to you about any one of these things. So I've got a really horrible diagram here, but hopefully it's clear enough for everybody to understand. This is a reference diagram I'm going to be referring to throughout the presentation. And what I've depicted here is essentially a traditional kind of network topology where you've got a firewall that's this item down here that's labeled DMZ. Let me see if I can pull up an arrow here for everybody. You've got a firewall there that's labeled DMZ, and that's an indicator that you've got a link from that DMZ into a virtualized or a physical machine where you're processing traffic for that DMZ. This is very typical for a lot of people to see. And then on the bottom side interface, we've got a web application firewall there, and that's looking at web application requests. And then on the left side of the diagram, you'll see a traditional switch, and then that's connected into a vSwitch. So we're going to be talking about this diagram. It may not look obvious what I'm trying to get at yet, but I promise I'll get there. So everybody understands the basics of virtualization. How many of you have deployed or familiar with VMware? Okay, so good crowd then. Everybody kind of understands the basics. So VMware is kind of the hypervisor on a host, and what it's doing is it's mediating the requests from an application or an operating system into the host itself. It's sharing hardware, it's splitting up resources, that kind of thing. You've also got a core, so that's a typical Intel processor. When we talk about cores here in the presentation, I'm just talking about a processor, but I want to be very specific and pedantic about it. We're talking about a specific element on that processor that you can send an application to. So when you're going through, you're creating a virtual machine, you're assigning a list of cores. Why is that important? Because it's going to talk about the performance of the elements I'm going to introduce as we get a little bit further down this. Everybody knows what a virtual machine is, so that's good. Anybody not know and need me to explain it? Okay. And then we have a virtual switch. So this is a piece that a lot of people don't understand the details of, and I want to talk about it. So in a traditional switch, right, you go buy a Cisco switch, you go buy a Juniper switch, Arista, pick a vendor, Brocade, it doesn't matter. That switch is basically a backplane connecting to different processors that also then connect to sub-processors that point out to different ports. The function of a switch is traditionally to take the MAC addresses that are learned from the hosts, store them in a very fast table that it can look up at very good performance, and then pass the traffic through to the MAC address that the port is on. So have host 1 with a MAC address of 0001, and I'll shorten it. And you have a host 2 with a MAC address of 0002. It's not obvious to some people that it's actually when host 2 first speaks his packet out that the switch learns that MAC address. I'm talking about this because we're going to talk about how virtual switches are different. So host 2 sends out a packet, the switch learns its MAC address, and then host 1, when it tries to communicate with host 2, the virtual switch knows immediately where to go. And that happens at a very high rate of speed, potentially in the microseconds on most switches, sometimes even faster. The process by which that's done is controlled by ASICs, or application-specific chips on the switch. A lot of switches have features where they carve up the table of the MAC addresses that they learn into different broadcast domains or different forwarding domains. So that's what you traditionally hear of as a VLAN. People quibble over these definitions. It's fine. I'm happy to talk in a little bit more detail about what I mean. So a virtual switch is very traditionally similar to that. But what it does that's unique is it's storing all that in memory on the host or in the processor. So it's emulating all of those custom application-specific chips. So why is that important? Why would I want to use a virtual switch as opposed to a physical switch? Well, because the virtual switch can do very different things than a physical switch can. It can be very flexible. So you can take a host that lives on one virtual machine host, so one VMware box. You want to move that VM to another virtual machine. The VM the hypervisor can just take that packet and copy it over to the other virtual machine. So you don't even have to know where the virtual machine lives, right? And there's a lot of things that can happen in a virtual switch that are things that network manufacturers, Cisco, Arista, Brocade, et cetera, are only now putting into their physical switches. So again, happy to talk more about that. But basically the idea behind a virtual switch is there's a ton more flexibility. How many of you have monitoring switches in your networks today? So switches that take network traffic and then copy it out to a toolbox or something like that. Nobody. Great. Perfect. So a monitoring switch is basically like a network tap that operates at scale. So that's me taking in, say I have 24 machines plugged into this monitoring switch, and I can tap the traffic of any one of those machines. And as an attacker, as an offensive attacker, I have no idea that monitoring switch is there. None. I mean, I cannot detect it at all from the outside. So it's a very valuable piece of functionality. But a virtual switch can also copy those packets from a virtual machine and send it off to wherever you want to send it. And again, as an attacker, I probably have no idea. So that's a useful piece of information we're going to return to in just a moment. So how does virtualization add to security? Primarily, it's through segmentation. So typically, if you put a large firewall in front of a series of applications, your model as a security person is to potentially add a new firewall for every application. That's a very expensive process. It's time-consuming, it's expensive in capital cost, and it's expensive in operational cost. So I'll give you an example. I have 3 hosts running a database, a web server, and something else. I may want to put a firewall in front of each one of those 3 hosts. Why would I not just centralize it on one firewall? Well, a few reasons. First, if I make changes to that one gigantic firewall, there's a cost to me because I have to retest my security after I make a firewall change. How many of you make firewall changes and then are required or directed to go and retest your application? Probably quite a few, right? So You make a firewall change to an access rule, especially if it's a manual change, that's a process that's subject to error. So it's very common to go through, make an access list change on a firewall, and find, oh, hey, I had some unintended effects because the rule was too broadly scoped or whatever. So normally, I would then suggest that you go through a penetration test after that. But that's a very expensive process. So it doesn't make a lot of sense to go red team every time you make a firewall change, because you're potentially making tens of those a week or a month or a year. So it's difficult. So virtualization gives you a way to do low-cost segmentation. And what do I mean by low-cost segmentation? I mean that instead of taking a physical firewall and putting it in front of every application, you already have a virtual infrastructure in VMware or KVM or pick your hypervisor. Just put a firewall in a virtual machine itself. I'm not talking about on the host of your application. I'm talking about something like a virtual SRX. How many of you have Cisco ASA firewalls in your network? How many of you have Juniper SRX firewalls in your network? How many of you have Palo Alto firewalls in your network? All three manufacturers have a virtual machine model of that firewall. All three. Same story with Fortinet. Same story with pretty much any firewall manufacturer you can name. So why is that important? Well, a virtual machine can be snapshotted. When you're making a change on a virtual firewall, you can create a clone of it to test your rules before you deploy. So that's a huge set of capabilities that you would not otherwise have. When you're doing that on a physical firewall, it is painful. The other idea that you might want to have with virtualization and security is functional separation. So maybe I want my policy to be controlled by another person in my organization. So you guys control the main firewall, and then you hand it off to the application owner to control their component. So as they're doing functional testing or things like that, that keeps them fast. It keeps projects shorter time frame. This is very good. It's also nice to be able to take snapshots. So if you've ever had a breach on an element in your network, you probably know the value of this, but since some of you have not, I can see, I'll explain it. As a security forensics professional, one of the most important things for me is capturing the state of an attack while it's going on. Because once I've discovered that there's an attack, I'm going to go in and I'm going to start trying to grab a forensic image of that machine. In virtual machines, it's literally 2 clicks. Grab a snapshot, move it off to an external forensics box, and I don't have to worry about it. Disk image, the whole nine. Now, that is not to say that virtual machines, including any virtual machine you can name, VMware, KVM, etc., perfectly secure. Some of you will have read in the past, and I mean I've read it too, that there are compromises to virtual machine hypervisors. Meaning, if you're in Amazon and you have a large-scale Zen deployment, Zen is an example of a hypervisor. Like let's say I'm on AWS, it's sometimes easy for me to find a bug in that hypervisor, be on an AWS virtual machine, and then immediately take another customer's traffic. So that is a scary piece. But I would argue, maybe other people disagree, I would argue that that's no different than the threats you currently face. So there is some value there in being able to take those snapshots. And it gives you it really shortens the time of doing a forensic analysis of a machine that's compromised. Excessively shortens the time. So grab an image, immediately go off and do what you want to do. So I want to talk about a few different models of security. And again, I've grossly simplified these diagrams. So when you're looking at this, please ignore my chicken scratch. This is kind of a traditional model where you've got a firewall and then a couple other firewalls chained off at the end of that, or maybe even switches chained off the end of the single firewall. The problem with this model is that when you are going through and making changes on that main firewall, you are affecting a very broad set of applications, potentially. You're affecting all the applications in your trust zone and all the applications in your DMZ zone. Why am I affecting the applications if I'm only changing the rules on one? Because most of us don't have tools to go through and ensure correctness of firewall rules. There are tools out there that do that, but most of us do not use them. So somebody puts in a change request and says, I need this new hole added to this firewall for this application. You're going to make the change on that firewall. It's very easy to fat finger that change and take too broad of a scope in the rule that you're changing. So how does virtualization solve that problem? Well, it would solve that problem by putting a firewall closer to the application, so you're limiting your scope. So your core firewall doesn't change, but maybe their application firewall does, which means that you can enforce your security policy as an organization and then give them some rope to be able to go hang themselves with their security. And maybe that's not the safest way to explain that to people, but I think it is a good way to explain it to people. Because your role as a security person, nobody has enough budget for security. Nobody has enough resources. I don't care who you are. You do not. So, and more importantly, the resources that you do have are often they're spread thin elsewhere in the organization. So the more that you can abstract policy down to a specific element, the better off you are. And, by the way, the more performant you are, because you're pushing some elements of policy processing closer to the application. And, by the way, it's cheaper. And you also don't have to buy as big of firewalls. So some of you know some of those firewalls, $500,000 a pop, easy. Virtual firewall, $2,000. By the way, functionality is similar. The only difference is the chips on the firewall itself. They run the same software. By and large, they have the same capabilities. There are some very minor exceptions, but you're not likely to run into them. And you get a lot more flexibility. By the way, not just limited to firewalls, right? Same story with IDS, same story with load balancers, same story with everything else. And we'll talk about those. And by the way, all those things, load balancers, IDS, everything, all elements of your security. So what I've described here, so if we look at this first model, you'll see this is somebody that put some firewalls in place, but where's my SOC? Where's my monitoring? Where's my everything else? Oh, and by the way, if I'm managing these firewalls, potentially I got one team managing the firewalls and seeing the logs, and another team managing the switches and seeing those logs, but actually there's security impact to both of those elements. So as a firewall person or as a security person, you want to try to take all of the information you can. It is needle in a haystack the deeper you go, but there are also tools to help mitigate that. So the ideal security model would be much farther down. We actually have a few slides to get there, and even then it's not perfect, but it'll serve for discussion. But the next step would be doing full-on security monitoring of all your elements. So how do I do security monitoring of all these elements? Well, that's a lot of data processing. That's another way virtualization can help me. If I have a ton of different element managers, so this is pretty common. I was actually talking with Matthew earlier about the number of element managers that he has in his network, right? You got a product from General Dynamics that has an element manager. You got a product from Cisco that has an element manager, like Cisco Prime Infrastructure. You've got other elements for your optical stuff. So you're taking all of that data in. You can't put all those element managers on one machine, right? It's going to slow it down. And a lot of those things have very specific requirements and systems configurations. So the idea here is that one of the things we can do is create a different farm of systems inside the Security Operations Center to take this data from all these different elements. So looking at the two of these systems, essentially now what I'm doing is I'm adding on components. So here we've got the application and the operating system. There's no hypervisor in this picture at all. There's no virtual machine. There's no VMware. There's nothing. Here we're adding host antivirus and host firewalling. So this is you configuring, Windows firewall on a box. And yes, that does help. Yes, you do want to do it. But you also want to be able to configure the network firewall. And so this model, this description, a little bit of an eye chart here. Grab this mic. And see if it works. Test. Okay, perfect. So this model is a little different. So here we've described a much more significant security infrastructure than what we did in the first couple slides. We started off with this basic diagram. We added these host antivirus and host firewalls, and then we have a vSwitch. But we still have our physical firewall over here. We still have another firewall here, potentially. Then we have a web application firewall. How many of you do not know what a WAF is? Okay, good. So we're taking our data in. We're distributing it out to different components in the network. We've got our host firewalls. We've got our virtual switch here. And we've got host IDSs. one of the things we're trying to do with this model is we're taking these intrusion detection systems and we're adding them on. So instead of just having one big intrusion detection system for the entire organization, we're adding additional elements. Now, smart people, I'm sure that's most of the room here, smart people will realize that those are additional elements that I have to manage. You're absolutely right. So there's a balance in this investment process where you're adding virtual components, you're adding virtual firewalls. Those are other elements that you have to manage and support as an organization. So it's not trivial, but the people that see this security domain, right, we're trying to separate out these into different security domains, may only want their traffic going to that first IDS. Maybe this is a top secret domain, right? This is going to the first IDS. Maybe this is a secret domain. It's going to a second IDS because this information might be classified. This information might be less classified, right? And then maybe I have an SCI domain down here going to another IDS. Go ahead. Yeah, absolutely, right? So, not only do I have these IDSs, there are a ton of other security elements I can put up here. There are IDSs, there are monitoring switches, and you see here I've depicted this monitoring fabric. You could potentially duplicate this entire domain and make it look like it's the real domain with a virtual model, right? You can take a whole copy of all this with fake data and make that into your honeypot. So that's much more attractive to an attacker, right? So this is really the promise of virtualization. So I'm going to get out of the way of this crazy diagram. Move back to reality here. So again, the idea that I'm trying to provide to you is that instead of continuing to buy physical firewalls, and by the way, I have no stake in either one, buy a physical firewall, buy a virtual firewall, does not matter to me. But instead of doing that, if you want to limit the domain of security and you want to be able to scale out as an organization, the idea would be that you'd add other elements that are local to that organization so that you're pushing the decision-making closer to the people that need to have it. And what I've described here is this isn't just about firewalls. It's also about web application firewalls. It's also about adding layers in between the host and the rest of the network. It's about adding IDS and IPS. It's about adding monitoring capabilities. It's about adding a lot of other elements as well. So I've talked about all four of these things, basically reducing the scope of the changes in testing on a virtual component, increasing the performance for a lower cost. So in other words, going out and taking one of these firewalls and giving it 3 cores on an Intel processor that only cost me $1,000 is much cheaper than going out and buying a $200,000 firewall. Performance is almost exactly the same. And there are documented results, right? This isn't just me pushing a manufacturer spec. Go look at the benchmarks from common organizations. You'll see that the performance is exactly the same. Where it's not the same is where you need to do that policy at a big centralized location and you're taking in multiple 10 gig interfaces. But for many of you, you're out focused on battlefield applications that are much lower performance. So in some ways, you're overblowing the firewall need because that's the lowest capacity firewall that person makes, right? Why should I buy a 100 or a 200 or a 1 gig firewall when my application forecast for the next year or 5 years or 10 years is maybe 50 megabits? It just doesn't make sense. So let me go buy a cheap virtual firewall. Let me put it on my VM that I already have deployed. And by the way, that's a much smaller footprint, physical footprint, cooling footprint, environmental footprint than everything else. How many of you are interested in software-defined networking? So that's a great number. So that's also something we do. Same story. We actually just built one of these chains for a customer where for every subscriber that they have to their network, they want to spin up an independent firewall, an independent IDS, everything. And literally, it's 0 provisioning effort on their part. When the subscriber's provisioned, it automatically provisions an SRX. It automatically provisions everything in the security chain. So that's something that's very common when you're talking about cloud computing. Go ahead. Yes. So I think it depends on who's doing the managing, right? So if the customer's doing the managing, which they are in some of these cases, it's decreased from the person that's providing the firewall. So I'm going to take an example from service provider land. If I'm a Verizon, for instance, or a level 3, and I'm providing you a cloud service and you want a firewall, it's in my best interest to get that, to not manage that firewall for you, unless you really want me to manage it, right? So for Verizon, it's a lower management cost because they're handing it off to you as the customer. For the customer, it's a higher management cost. So you don't get away from the ability to manage it, although there are some things in software-defined networking land that actually make that process a whole lot easier, the management process of a firewall. And by which I mean, at the moment you deploy a new application in the software-defined networking world, it can automatically tell the firewall, hey, I'm rolling out this new application. It's at this IP address. Please copy the rules that I already had in place for all these other applications that meet the same profile. Let me just deploy it to that host. Yeah. So one of the big advantages of this virtualization approach is basically being able to take all these elements, and the same way we do with virtual machines, right? You build an image, you copy it out to everything else that meets that image, and then when you make a change on the first one, it propagates out to all the other ones, right? So in a way, it does reduce the cost if you've automated those things. And more importantly, in a software-defined networking / cloud computing / name your buzzword this week world, you can have all those elements working closely together to provision one another. And there is some security impact to that, both positive and negative, but it's always a trade-off. Everything we do in security is a trade-off, right? Always a trade-off between cost, between the risk, how serious we think the risk is, because we can talk about risks all day, but maybe my perception of that risk is lower than yours, but I think it's important to keep in mind. It also does make our reliability concerns somewhat different. I would say it minimizes them. Other people might disagree. The idea that I can take a firewall and image it and have all the rules and then do my testing of my application in a new environment makes a lot more sense to me. Because that way I don't have to affect my current application. I know what the real world environment is. I have a snapshot of it. I know what it was like on this day. So let me take it and move it forward. So just a few diagrams here. I promise I'm not going to elaborate too much on these. Basically what we're talking about in these diagrams is a model where we've put these firewall virtual machines in place, these web application firewalls, these database firewalls, and we virtualize them. And what you can see on this diagram is I've got a VLAN in between this firewall and WAF VM. That can all sit on one host. So you think about a traditional firewall where you've got an outbound or an untrusted interface and then multiple inbound interfaces, trust, DMZ, etc. The idea that you've got those multiple inbound interfaces basically allows you to make a VLAN be those interfaces. So you're virtualizing the interfaces as well. So if you look at the SDN world, we have this idea of a left interface and a right interface. And maybe your right interface is to the internet and your left interface is inbound to the host. If you're left-handed, it might be reversed. But the idea there would be that you're building network infrastructure virtually. So you can add as many interfaces as you want. This gives you a lot of freedom in terms of how you want to architect your security profile, because it doesn't matter what the physical profile is of all your different elements. You can have whatever virtual profile of those elements you want. And so that's what we've essentially described here. And so what I've done here in these next few slides, kind of a waste to go through it in some detail, but just talking about the way that a virtual switch handles a packet. So the physical switch knows that this hypervisor has the following MAC addresses for the hosts. And what we're basically describing here is the virtual machine learns those MAC addresses, rewrites the MAC addresses where appropriate to the hosts, and does the processing. But again, this is all happening within the hypervisor. No physical firewalls. Okay, so basically I've taken what normally would be, by the way, 3 firewall VMs for different applications, a WAF and a database firewall. So this is like $1 million worth of equipment, right? And it's now $10,000. Seems like a pretty useful statement to me. Go ahead.
So if you're going
Yeah, please.
Network, right?
Can't do it this way, right?
Right. So
Yep.
you're going to have a whole separate hypervisor, a whole separate host, a whole separate everything.
That's right, yeah. And I don't want to minimize that, right? And I think that's something that some people don't think about. Like I talked about earlier, the hypervisor compromises, they do happen. So this is not something that you can just ignore. But, go ahead.
Yeah, I've seen instances where you've enabled the NICs, like with the SE Linux type of VM,
Yep.
with KVM, and you can do at least 2-level virtualization.
Yeah,
in the box.
absolutely.
So
Yeah, and there are ways to add to the security of this possible model. And I don't want to minimize something. If you've got an SCI application, you don't want to necessarily put all that on one hypervisor. You want each program in its own VM or in its own hypervisor. But if you have a bunch of applications that share the same security profile and the same risks, and the data is the same classification, and maybe it's even in the same program, there's absolutely no reason why you couldn't necessarily do this model. But again, what we're doing is we're not mandating that everybody should do this, right? What we're saying is this is flexibility for you that a lot of people don't think about when they engineer around security applications. So I've got a lab at home, right? I've got 5 servers sitting there in that lab. I've got 250 VMs. All of them have a different security policy of 30 domains. And literally all I've done is I've put virtual firewalls everywhere. And the performance, if I put an external tester like an Afcea on it, or a Viavi box or whatever, and I do that testing, just the same as it would be with a physical firewall.
So is this technology similar to like VMware micro-segmentation?
It's exactly the same thing. Actually, I've got a slide in a couple moments that talks about that. So what I've described here is the idea that we might put a VSRX in place, but you can do the same thing with VMware VMware NSX with the Palo Alto stuff. So I'm sure a lot of you have heard that story. And it's a good story, right? There's no reason why you should. I think all these principles apply just as equally to that as they would be to going and buying another firewall. I also want to talk about something that's a little related to this that I think maybe we were about to touch on. Some of the firewall manufacturers also have virtual machine functionality within their firewalls. So in Palo Alto land, you have these virtual domains that represent different security elements. So that's not strictly what I'm talking about, but that's just as applicable a domain as anything else. Fortinet, Juniper, Cisco. Cisco's got virtual contexts. Fortinet has VDOMs. They're all kind of similar models. So that's virtualization inside a physical firewall, which also gives you some flexibility. I don't think it's anything less or more than the flexibility that you might be getting here. Our goal here is to try to put tools in the toolbox, not necessarily figuring out what applications meet the right security profile to do each of these is that's a separate exercise, I would say. So another important thing I want to mention is that we talked earlier about this idea of a monitoring fabric. The virtual switch can take each one of these different applications and tap the ports independently and send it to a third host. So, for instance, I might tap this specific application rather than tapping the whole security domain. And there are some security domains in which I'm prohibited from tapping that application. So, by the way, all those rights, especially in VMware, controlled at the user level. So you can give the application owner some control over what they tap. All right. So, again, just talking about the idea of having an IDS or a tap there and splitting out the different IDSs. So like I mentioned a few minutes ago, all of these particular security elements are now available in virtual form. There are others that are not listed here. Firewalls, application firewalls, database firewalls. F5 has got a great appliance. It's basically everything that's in an F5 box you can put in a virtual element. Same story for Citrix. Same story for A10. All of them have that capability. So if you're not talking to your OEMs and your VARs and your sourcing partners and everything else about this stuff, maybe it might be a good time to start talking about that. Because I think you'll find that the price is a lot lower, and it's not very well publicized either. So Juniper doesn't advertise any of these things. Palo Alto doesn't really advertise the pan VM model either. So it's useful to talk to people about that and to ask and find out if it fits your application. All right. So again, just to kind of summarize and bring all this back home. How are we using these tools to solve problems? We're basically taking our segmentation that right now we might do on a single firewall, multiple firewalls, and doing segmentation that's closer to the application at hand. And it can still be in the control of the network team. Some of you have different network and applications teams. So the applications team owns one domain. They don't want you messing with the configuration of their box. But as a network person, you might want to give them a specific security policy that they can control. And that's one way of doing that. You reduce your audit scope to some extent by adopting these tools. It's not inherent, but by shifting the security policy and minimizing the domain, you are reducing that scope. We see this a lot in networks where we do payment work, payment compliance. Same story actually in the HIPAA world, where we've actually taken all of the security policy that normally be handled by a traditional firewall and made it just applicable to that specific domain. So we can figure out on a per floor or per unit basis in a hospital what the security policy might look like for that area. One of the other capabilities that we get with all this is that when the application moves, this is a very common need. When you have a virtual machine and you're taking that virtual machine and you're moving it to another hypervisor, wouldn't it be nice to move all of that security policy when you're doing that process? So I think that's really important. I think it's nice to be able to just pick up all of the VM elements and move them over and have everything just come up correctly on the other side. So when you're doing data center failover, somebody blows some artillery shells into a data center, you lose the whole thing, or container or whatever, you're able to take that data and move it over to another data center from backups, and everything just keeps on ticking. The other important technique that we talked about is being able to do taps on a per machine basis or per firewall or per VM basis. I hid this slide, so you're not going to see it on the web, but I hid it here. The other interesting technique that we've seen in the past year or so is containerization, basically taking the applications and putting them into a container. How many have heard about Docker? Just a couple of you. How many have heard about containerized applications more generally? Okay, a few more. So the idea here is that we've got another layer of virtualization sitting on top of the VM. And that container that hosts that application can have very different network rules and policy than even the VM might have. So if you need to dive down to another deeper layer of abstraction, you can do that. So in summary, I think my key message to you is this, that doing security policy on single big monolithic firewalls, IDS, IPS, load balancers is a risky proposition. And it's a risky proposition because it increases your need to test. It increases the likelihood that something will go sideways in the policy. And it also makes your OpEx more expensive and your CapEx more expensive. In the sense that if you go buy a big firewall, that firewall's $1 million, where you might have just needed something really small. But you didn't have flexibility in how you deployed it out. So I think having that flexibility is really important. Also, if you are not focusing on monitoring your applications separate from the firewall and monitoring your network separate from the firewall, you should be. Everybody should be putting monitoring switches in their networks, taps, because as an offensive attacker, I don't see those. So I don't know whether you're sniffing that data. So when I first get in a host, what am I doing, right? Going back to this kill chain. When I first get into a host, and I've exploited that host, I'm trying to pivot to the next host in the chain, right? But before I do that, I'm going to try to erase my logs. Hopefully all of you have immutable log infrastructure. It's write once, and you can't rewrite that log. Great, perfect, fabulous. But if you have a monitoring switch in place that's writing to an out-of-band location that I never see, I promise you'll have more forensic data than you might otherwise have. We talked earlier, just one more discussion real quick, about this people training social engineering defense and about the intelligence side. So if you have not gone through a threat modeling exercise, you should do that. Go visit the Microsoft folks. Go talk to us. Go talk to somebody else. They have a great author, Adam Shostak, who wrote a book on threat modeling. We're giving that away. So if you guys want to take a couple minutes, you can just click on or go visit this link, including on mobile. Fill out some information. You'll enter a drawing to grab that book from us. We'll ship it to you. So that's it. Questions? Okay, if anybody wants to talk SDN, virtual security, drop me a line. I'll be down in the Walker & Associates booth later today if anybody has any questions. Thanks so much.